right, so we are back. We are going to continue working with exponents and radicals. Make sure that you are writing your notes down. Okay, so make sure that is happening. Like I said, we're still going to be working with radicals, exponents, all of that. So what we're going to be doing today, if you want to label the top of your page, we are doing rational exponents. We'll also be working with some other nth root radicals, but we're just going to label this one as rational exponents, so that way we are good and ready to go. That being said, what a rational exponent is, like normal, we're going to start with some definitions or laws. So the first one is if I have b to the 1 over n power, that is the same thing as writing it as, let me zoom back in here and move my cursor so that way it doesn't do it again, is equal to n square root of b. If you're wondering where that 1 went to, that 1 is now right there. So, in other words, maybe you'll see this form. You might have b to the m over n power. That just means that I'm still going to have the n as my radical, as my root, and that m is going to stay on the b. So basically the m, or the numerator, stays with the exponent, stays as the exponent. So the numerator in that exponent stays as the exponent, and the denominator becomes the root. A lot of you were asking me, when we used to have exponents that were like this, we would change them into fractions, have to do a whole lot of stuff. This is just a simpler way to do it. So if you have a fractional exponent, this is how you solve it. So one more thing that you need to know, when the base number, so when, remember with our exponents, your large number, this is considered the base number. And whatever you have up here, I'll do m over n. This here is considered the exponent, just as a reminder. So when the base number and I'll abbreviate, the base number is less than 0, and 0 is an important word there, so when it's less than 0, the denominator must be odd. And here's why. So odd is your important word there. Here's why. So if my base number is less than 0, let's say my base number is -2, and I have m, and I have 1 over 2. I'll just use something simple. So I have, it's less than 0, so I fulfill the first requirement, it's less than 0, but I'm going to make it even instead. I'm going to make the denominator an even number. I'm going to make it 2. That means that when I'm flipping this, my root becomes 2, and I'm taking the square root of a -2 to the first power. Well, anything to the first power is itself. And if you took last week's notes, you know that if you take the square root of a negative number or any even root, I could make this number here any even number. What's going to happen is it becomes undefined. If you type that into a calculator, it gives you an error. So that is why you can't have an even root. So this can't be done. This is not correct. I'll put an X there because it doesn't work. But you could do it if it was odd. So if I had -2, 1 over 3, that just means that I have the third root of negative 2 to the first power. So just taking the third root of negative 2, and if you type that into a calculator, it will give you an answer. So that is why. So what we're going to do first is we're going to just work on going back and forth with these things. So if I was to give you 28 and make my exponent 1/2. Remember, your numerator stays as your exponent, and your denominator becomes the root. So I'm greater than 0 for my base. So it doesn't matter if my root is odd or even. So then I can just rewrite this as the square root. I'm going to put the 2 on the outside of 28 to the first power, or the square root of 28. That's all that you have to do. We'll come back and simplify this later, but I want to make sure that we get one more example in here. So the next one, I want to rewrite in radical form, but I'm also going to evaluate. So remember that the word evaluate means simplify as much as you can. So I'm going to evaluate negative 8 over negative 125 to the 1/3 power. So when I have the 1/3 on the outside here, does it go to just the numerator, just the denominator, or does it go to both? I'm hoping that all of you are thinking that it's going to end up going to both, meaning that I'm going to have negative 8 to the 1/3 power and negative 125 to the 1/3 power. I'm going to take this exponent and distribute to both the numerator and to the denominator. So the first thing I see here when I simplify this and distribute that in, I have a negative in the numerator and a negative in the denominator. So a negative divided by a negative is a positive. So I'm just going to cancel those out right now. So now I need to rewrite this so that I can visualize what I'm actually doing. So I will have the cubed root, because remember the denominator becomes my root value, over 8 to the first, which is just 8. And then I'm going to have the cubed root in the denominator of 125 to the first power, which is just 125. So if you use your reference sheet that you should have made last week, if you didn't, this is in another Edpuzzle video. I am looking for cubes. I have a 3 on the outside, so I want to look in my perfect cube column here. So since I have cubes, I'm going to be looking for cubes, and I'm looking for the numbers of 8 and 125. So 8 is here, which is 2, and 125 is here, which is 5. So the cubed root of 8 is 2, and the cubed root of 125 is 5. So I'll go back to the other page. Cubed root of 8 is 2, because I'm basically doing, and I'll write it out the long way, 2 times 2 times 2 to get 8, which means I have one group of 2s, because I have grouped them by 3s here. So I have one group of 2s, so I just have a 2. And then I have 5 times 5 times 5. So that means I have one group of 5s, so I have 5. So when I'm simplifying that, this would be my final answer. I cannot simplify that fraction, so we are good to go. So that is all this part is. That you're just taking whatever the base number is, putting it on the inside of the radical. The numerator goes with it. The denominator becomes the root. You're just going back and forth like that. So if I was to say, let's go the other way. So I'm going to label these examples for you so that way you have them. This is example 1. And then we have example 2 here. And then we'll have example 3 here. So I want you to write radical 47 as an exponent. or in exponential form is how I'll write this. So write 147 in exponential, or the radical of 47 in exponential form. So if I have nothing outside here, we automatically assume that it is a 2. So I know that the denominator, remember whatever here is my denominator in my fraction. And I know whatever the exponent is on the inside is the numerator. And since there's nothing there, we assume it's a 1. So I'm going to have the base of 47, because that's the large number on the inside. And my exponent will just be 1/2. That's all you have to do there. And just like last time, sometimes we're going to have some variables thrown in here. So let's go backwards again, and let's change the cubed root of 3, a to the 5th, b to the 2nd, to exponential form. So this one might be a little bit trickier. So basically what's going to happen here is I'm going to have 3 bases. I have a base of 3, I have a base of a, and I have a base of b, because my exponents on the inside are 2, 5, and an invisible 1 on this 3 here. Remember, the outside number is my denominator. So I'm going to have 3, 1 over 3. Then I'll have a, 5 over 3. And then b, 2 over 3. And that's all it is. That's all you have to do when you're going back and forth. And the other thing we looked at last week was sometimes we have decimals. So one more example, and then I'm going to give you a few to try. So sometimes we end up with decimals, such as maybe 0.03 to the 2/3 power. We're going to go to radical form. And you would write this one then as 3.03 to the 2nd power. And then you could type this one into a calculator and solve it. And if you were to type it into a calculator and solve it, you would get 0.097. Just as a little bit of a reference for you. So that being said, I'm going to give you 2 for you to try on your own. So we're going to go to the you try. And the first one I'm going to give you is to go to radical form. And I want you to change 303 over 2. And the second one that you're going to do, so number 2, you're going to go to, let me see here, let's go to exponential form. And you're going to change the cubed root of 3, a to the 7th, b. So those are the 2 that you are going to try. So try them first, and then we'll come back and we'll go through them. So when we go through these, the first one that you want to look at is, we know that the denominator is the root and the numerator is the exponent. So the denominator of 2 is my root, and the numerator is the exponent. So 300 to the 3rd power. Don't worry about actually doing 300 to the 3rd power. I'm just looking that you can get this form. And then if I'm changing to exponential form, remember, I actually have a 1 here in the numerator and a 1 here in this numerator. So I'm going to have 3, 1 over 3, a, 7 over 3, and b, 1 over 3. That's how you're going back and forth for each of these particular problems. So the other thing that we're going to do is, last week we were going through these nth root problems. And sometimes you had to use a calculator, and the way we identified them using a calculator is in two different ways. One, maybe it was a prime number. So we would need to use a calculator if it was like the square root of 13. 13 is a prime number, so there's nothing that would multiply to become that. So what we're going to do there is we would just type it into a calculator. Sometimes we aren't that lucky though, and we have numbers like the square root of 15. So what you could also do is look through your list of squares, and I would say that I go from 9 to 16. So I don't have a 15 in there, so I'm going to have to throw it in my calculator. There might be times, though, where you don't have a calculator on hand very quickly. So we look at something, and I tell you to simplify it without using a calculator. You're going to have to change it around so that it becomes a radical with a number on the outside of it. What I mean, so for these, we're just doing what we did last week. There's still nth root radicals, so I'm going to section this off and do nth root non-perfect. So we might have something like the square root of 50. And I'm going to say to simplify this radical. So we're going to simplify it. I don't necessarily want an answer, but I want it to be as simplified as we possibly can. So if I'm thinking about what the square root of 50 is, I need a number that I can take the square root of. So something that is in my first column on my reference sheet. So I'm looking for the first column because it's a square root, so I'm looking at the squares. And I'm looking for one of my numbers that goes into 50. So one of the numbers in this column here that goes into 50. The other way I can do this is I can think about what are the factors of 50. So if I'm doing factors of 50, what I'm going to do is, okay, I know that 2 can go into 50, and 2 times 25 is 50. And I can keep going. So 25, I know that automatically right off the top of my head, the first one that I think of is 5 times 5. So I can stop here because a square root means I need to have a group of 2. So if I'm in a square root, I need a group of 2 that I can pull out. So 5 are prime numbers. So this is another reason I know that I can stop. So these are prime numbers, meaning that I can't simplify them. I can do 1 and 5 and then 1 and 5, but that's not going to get me anywhere because I can just keep going and saying that 1 and 5 is the square root, which isn't really going to do me any kind of good. So I don't want to just keep going and writing 1 and 5 over and over and over again, so I'm going to stop right here. So this is my group of 2, meaning that I can pull out a 5, but this 2 here has to stay on the inside. So I'm going to simplify this to become 2 square root of 2 with a 5 on the outside. So 5 radical 2. That would be how I simplify this. I could have also stopped right here, up a step, and I know that 25 is in my list of perfect squares. If I had gone through here and I was just looking for something that goes into 50, I could have pointed out that 25 goes into 50. So there are going to be others like we had here. So maybe I ask you to simplify, so this is example 1. Maybe I ask you to simplify the square root of 500. So I know that 100 times something is 500. 100 times 5 is 500. I could have started with 2 goes into 500, and I eventually would have gotten there as well. So if you wanted to start with 2 times 350, and then you could keep simplifying this part down as well. So if I did 2 times 350, and then I know that 350 divided by 2 then is 175. And then if I did 175, I know 5's go into things that end with a 5. So I could do 175 divided by 5, and I find that 5 times 35 gets me someplace. And then I could divide that by 5 and get someplace. And I got 5 and 7, and both of those are prime numbers. I can only multiply 5 by 1 to get 5. I can only multiply 7 by 1 to get 7, so I'm going to stop there. On the other side, I know that 100, I could do 5 times 50, 5 times, I'm thinking of 2's, 5 times 20, 5 times 20. And I know that 20, I can do 5 as well, and I could do 5 and 4, and then 2 and 2. So, if I'm looking through here, I have 1, 5, 2 5s that I can now pull out. And then I've got a group of 2's that I can pull out. If I'm looking at the other side, I've got 2's and I've got 5's that I can pull out here. Either way, you're going to end up with the same answer. I biffed something up here on this other side. So I'm going to go ahead and stick. Let me see if I can even find the mistake. If you find the mistake, I'll give you a chance to say, Miss K, I found it, in the notes on the side there. All right, so and here's my mistake. I said that 500 divided by 2 is 350. It's not. It's 250. So 250 divided by 2 is 125, not 75. Divided by 5 is 25, which is 5 times 5. Both of those are still prime numbers, so here is where I biffed up, found it. Either way works. So this means if I'm looking at the column on the left, the only number that I don't use that's by itself in my tree is this 5. So the 5 will stay on the inside, and I can group the other 2 on the outside. On the right column, again, the 5 is the only thing left in my tree. I've got a group of 2's and I've got a group of 5's. So I'd have a group of 2's and I have a group of 5 on the outside, and then I have a lonely 5 left on the inside. So 2 times 5 is 10, so I'd have 10 radical 5 as my final answer there. Another thing I could have done, I know that 100 is on my list of perfect squares. It's right here. And then I could go back and look and say, okay, what number maybe on the other column is in the perfect squares? So is 250 in here? 250 is not in there. So if I keep going to the next one, I could say, oh, but 25 is in there. And I know 25 is 5 times 5. So there are multiple different ways you can go about this. None of the paths of finding them are wrong, but you might find a different way than somebody else did it, and that is totally fine. You'll still get the same answer, assuming that you didn't make a mistake like I did, and we all make them, so that is perfectly okay if you did. In fact, making mistakes is the best way to learn. All right, so I've done 2 of them with you, so I'm going to go ahead and give you a few you tries. I'm going to give you 2. So the one I'm going to give you is I'm going to give you the square root of 54, and I'm going to give you the square root of 80. So go ahead, try both of these. This is the first one. This is the second one. The steps, if I was to give you it in a different root, so if I was to give you it in the third root, you would do the same thing. You just need groups of 3 instead of a group of 2. So either way, both of these are ways that you can do them. Neither way is necessarily wrong. All right, so coming back to this, I know that 54, if I'm going through, I could do it by 2 first. So 54, if you're looking for things, 54 divided by 2 is 27. I know 3 goes into 27. And I've got 3 times 9, and I know 9 times 3 times 3, is equal to 9. So I've got a group of 3s, and then I've got a 2 and a 3 that are left hanging off here at the end. So on the inside of this one, I'd have both a 2 and a 3. And then my group of 3s, remember, comes to the outside. 2 times 3 is 6, so I'd have 3 square root of 6. The next one, I've got 80. So again, I know automatically it's an even number, so I can divide 80 by 2, which gives me 40. I know 40 is an even number, so I can divide that by 2, which gives me 20. I know that I can then divide 20 by 2, which gives me 10. And I can divide that by 2, which gives me 5. So I've got a group of 2's here, and then I've got a group of 2's here, and I've got a 5, let me use a different color, a 5 all lonely over here. So my lonely 5 that doesn't have a friend goes on the inside, and I've got 2 groups of 2 on the outside, giving me 4 radical 5. So you should have gotten 4 radical 5. All right, so like normal, I'm going to give you an exit ticket where I don't necessarily give you the answers, but it gives you a chance to try a few more on your own. So this is your exit ticket for today. So the first one on your exit ticket, you're going to put in radical form and evaluate. So, I mean, simplify it as much as you can. So I'm going to give you 4 with the exponent of 3 over 2. So that is your first question. You're only going to have 2 questions today. I'll only give you 2. I'll be lenient and give you little to do. So there's that one. And your second one, you're going to simplify the square root of 45. So go ahead and do those as your exit ticket. You'll answer them at the end like normal, and I will have an explanation in there for you automatically so you know if you got it right or wrong. If you have any questions, make sure you put them in the question box. I do comment back and give you answers, so make sure you're asking questions if you have them. If you are going through the assignments after this and you have questions, make sure you hit the ask button. Usually there's an ask button. If you're using Alex, that message button sends it directly to me. I can see the question. I can see where you're stuck. You can ask the question right on there. I will have at least one. I'll have times that you can contact me, that you can even just set up a Zoom with me, and I can answer questions live with you. So ask questions. Make sure you're working through this. I know you are all smart, and I miss you all. All right. Something that I want to throw in here before we end this video is sometimes you're going to have something like the square root of u to the third. So if we think about this, that means that I have a total of 1, 2, 3 of them. So I can make a group of 2, so I can pull 1 to the outside, so I'd have u on the outside, and I would have 1 left over on the inside. So that would be my answer. If I had the 5th root of v squared u to the 7th, I can't do anything with the squared one because there's only 2, and I need things in groups of 5. But my u to the 7th, I have 7 u's, so 1, 2, 3, 4, 5, 6, 7, and I can make a group of 5 with 2 left over. So the 2 will stay on the inside, and 1 will come to the outside. So I'll have u in the 5th root of v squared u squared, since there's 2 left over. So you are going to see some of these in the Alex assignment. I'm not going to have you practice any here, but make sure that you do keep that in mind because you are going to see it a little bit in the Alex assignment.